Hello everybody, welcome back to another video on math. Today we're going to be talking about algebraic circles using algebra. Really this is just circles and their equations. So like many things in algebra is a more quantitative representation of geometry using numbers and stuff. So yeah, let's get to it. So the standard form of a circle is this. Without getting into the derivation of this formula, this is the formula. All right. X minus y minus, and then we can say h and k. So the spot where I just use those red letters H and K, that represents your center. So you would say that this has a center at H comma K. You notice how it's minus H there? So you'd express a positive H in your center. Minus K, you would express a positive K. And then your radius is actually the square root is going to be the square root of r squared, which just is simply equal to r. So this spot right here, take square root for finding the radius. Okay, so I have a little coordinate plane over here. So I'm just going to make up a circle right now. Yeah. Slide that over there. Example. X minus 3 squared plus y minus 5 squared equals 16. So the center is going to be 3 comma 5. And that's going to be 1, 2, 3, 1, 2, 3, 4, 5 right there. And the radius is going to be the square root of 16, which equals 4. So then we go over to our circle and we count 1, 2, 3, 4. And then typically what I do is I count left, right, up, down, or right, left, up, down. 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, and 4. Okay, and then I draw my circle. I'm going to try my best to make a perfect circle here. That came out pretty good. Not too bad. And you know, I mean, if I really wanted to get into it, you know, that's to make it more perfect. Could do that. Okay. So that's pretty much the overall gist of that. If I were to say change this to a positive, what do you think would happen? Yeah, this would become negative here. So it would be at the center would have been at 3, negative 5. However, the radius would have stayed the same. I would just have to take the circle and move it to 1, 2, 3, 1, 2, 3, 4, 5, and it would have been right there instead. Not a big deal. All right, moving on. Let's do an example. So why don't you pause the video and see if you can come up with the center and the radius. And just for kicks, why don't you hit me with a area and the circumference. Okay, welcome back. The center, as you can see, is going to be, let's change the color of this to blue. The center is going to be negative 4, comma positive 2. The radius is the square root of this number right here. But remember, that number is r squared. So we have to take the square root to actually find the radius. That's 5. And then the area is pi r squared. So it's going to be 25 times pi. And the circumference is pi times diameter, or 2 pi r, which is going to be 10 pi. And if you want to plug that into a calculator, knock yourself out. So, and let's say units squared, and just units Oh, I spelled units wrong. All right. 1, 2, 3, 4. 1, 2. There's my center. And then the radius is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. There are many ways you can draw a circle. I don't know if anyone's ever taken a drawing class, but you could make it a little bit fuzzy. You could just kind of do your best to get that curvature in, and it kind of looks like I'm trying to draw Oscar the Grouch or something. And then that's enough. You know, you're sketching. If you have a fun tool like this iPad, of course you could just come in here and spice it up and draw something special, like a perfect circle. Because, you know, in this, using technology, it pretty much knows you're going for a circle, and then it draws it for you. Okay, moving on. This one's actually easier than the last one, but why don't you give it a go? Pause the video. Welcome back. Center is 3, 0, and the radius this time is going to be the square root of 32, which is equal to some decimal. So the square root of 32 is 5.7. So it's about 5.7. Now, why do I care about that? Like, why do I write it as a decimal instead of square root of 32? Well, do you know where the square root of 32 is? Like how to count that on a coordinate plane, because we're trying to sketch this thing, right? Anyway, so there you go. And then we have the area is pi r squared. Well, I have good news for you. Pi r squared is going to be, this is right here, r squared. So it's just pi times 32, or 32 pi. Nobody's asking you here for a decimal. You can just leave it in terms of pi. Units squared. And the circumference, now this time you should take half of the, I'm sorry, not half, you should use the square root there. So because it's 2 pi r, so the radius is going to be 5.7, or the square root of 32. I'm feeling like I like leaving this in an exact mode. So I'm going to say 2 times the square root of 32 times pi, so 2 pi r, so yeah, it's 2 square root of 32 pi units. Okay, again, you could plug that into a calculator, get a decimal answer, but that's how you do that. And the reason I found a decimal for the radius is for the graphing purposes only. So that center is at 3, 0. So we're going to go 1, 2, 3, 0, and then we're going to count out 5.7. 1, 2, 3, 4, 5.7. Like I had mentioned, you might want to just go that direct, just go up, down, left, right to get all of those points, and then you can go 1, 2, 3, 4, 5.7. 1, 2, 3, 4, 5.7. And then draw your circle to the best of your ability. Make that a little bit bigger. Good. All right. There you go. Now we're gonna change directions. And this is where I start to lose students. I mean, when you're just given an equation and it's clearly you can find the center and you can find the radius, you're good to go. I probably didn't mention this before because I just, I take for granted that you already know this, but the most defining characteristic of a circle, as you just saw, is the center and the radius, right? Because what is a circle? A circle is an infinite set of points that are equidistant to a center, right? An infinite set of points that are always the same distance to the center point. That distance being the radius. So if you know the radius and you know the center, then it's easy to sketch that in a coordinate plane. So as with everything in mathematics, it's nice to know how to do something, but it's also nice to know how to undo something. Just that way you know how to work in both directions. So if you're given the equation, if you're given the center and the radius, or you have a center and a radius, or you find it or whatever, then you can easily find the equation of a circle just based on what we just did. So let's just review what the standard equation of a circle is again. Standard equation of a circle is going to be x squared plus y squared equals r squared with center at h k. That's an h, yes. HK. So all we need to do is take this center and this radius and plug it into that equation, and we're good to go. So where you see an h, you replace with 5, because this right here, that's my h, and that's my k. So you let h equal 5, you let k equal 3, and then we let r equal 2, and we substitute it in to that equation. Why don't you pause the video and do this, because I know you can do it. All right, welcome back. We have x minus 5 squared plus y minus 3 squared equals 2 squared, which equals 4. And that's it. So we're going to spend the rest of this lesson writing equations with just by adding more layers of complexity. So of course if someone just gives you a radius and they give you a center, then you're done, right? Just plug it in, you're good. So they're going to make you work for it a little bit. So this time they say, write the equation of a circle when you have a center 0, 9, diameter 32. Pause the video. Okay, welcome back. Hopefully you realize that there is no diameter in the algebraic equation. You need the radius, and we know that the diameter is double the radius, so that means the radius in this case is equal to 16. And we're going to have x minus 0 squared plus y minus 9 squared equals 16 squared. X minus 0 is just x, so you're left with x squared plus quantity y minus 9 squared equals 256. So there's your equation. Now, you could use a program like Desmos or any graphing calculator for that matter. Well, actually, no, I take it back. Regular graphing calculators will force you, like a TI-84 or something like that, will force you to solve for y in terms of x. It doesn't let you implicitly graph. But Desmos or any computer calculator, an online calculator, typically will let you just type in the equation as it is. So like the equation we just created, x squared plus y minus 9 squared equals 256. Let's plug it in here and just test it out. X squared plus quantity y minus 9 squared is equal to, and that's 256. All right, so we know that the radius is 16, and when you look, you can see, sure enough, the center is at 0, 9, and if you were to count out, you can see right here at this point that we're actually at exactly 16, 9, right? So, which totally makes sense. That's where the center is, and it's like on the diameter and stuff. All right. So if that makes it a little bit more fun for you while you're doing these find the equation exercises, have at once you use Desmos. I'm not going to do that every single time, but now you know. Moving on. All right. So again, more layers of complexity. It's like, oh, gee, they gave me the circumference. What am I to do? I have a center. I need a radius, right? So well, we know that the equation of a circumference is 2 pi r, right? So, and they gave us a circumference. It's equal to 6 pi. So what we need to do is we need to solve for r. So how do I isolate that r? Divide both sides by 2 pi. Divided by 2 pi, divided by 2 pi. And then you end up with r equals 3. I bet you there's a handful of you that are like, hey, hold on, circumference is also pi times diameter, so clearly 6 is the diameter, then you divide by 2. That's great, but they don't always give you nice numbers like that. They may give you a circumference that's not in terms of pi, and you'd need to use a calculator to get a decimal equivalent. I would just still write the equation out. All right, so now we have our radius. Now we're back to an easy problem, and we say x plus 1. Why is it x plus 1? Actually, you know what? This is the first one, I think, where it's negative, so let's try again. We're going to say x minus negative 1. That's the h term. Quantity squared plus y minus 4. Quantity squared equals 3 squared. Then you have this double negative 1 here, so that's why you'd go x plus 1. Quantity squared plus y minus 4 quantity squared equals 9. That's your final answer for that problem. Okay, keep on going. So this time they give us an area. Again, you've done these exercises before, so they just want you to find the radius based on that area. So we know the area is pi r squared, and they gave you the answer to the area, which is 16 pi. So we need to solve for r. Well, actually, you know what? We can just solve for r squared because that's all we really need, because we're going to be squaring it anyway. So you divide both sides by pi, and then we get r squared equals 16, which means that r is equal to 4, but who cares, because again, the equation is x minus h squared y minus k squared equals r squared. So we're going to have x minus negative 8, which is plus 8, squared plus y minus negative 11, which is plus 11, squared equals 16. Again, I'm not going to square that because it's already squared. R equals 4. 4 squared is 16. Okay. We're doing pretty well here. We're almost there. Yeah, that was a bad circling job of that, but I'm not going to fuss with that anymore. We're going to move on. Okay. So last one. This is probably as hard as it's going to get. I would like for you to look at this problem, pause the video, right, and then see if you can come up with this on your own. I believe that you can. Right. All right. The center is at 9, 10, and we have a point on the circle at 7, 4. In order to find the equation of a circle, I do need the radius and I need the center. Once again, I have the center. How am I going to find that radius? In order to find the radius, you have to think about the definition of a circle. So the definition of a circle is you have a center, right, and a radius. I keep saying that. So let's just sketch this the scenario real fast. So we have a yx, and 9, 10 is probably somewhere over here. Again, not drawn to scale. 9, 10. And then we also have 7, 4. So we're going to say 7 and 4. It's going to say, let's say that's like right here. 7, 4. This distance right here, if this is my center, and this is just some random point on the edge of my circle, and we can draw, oh boy, I'm going for a circle, please, yes, and then we can draw a circle. Actually came out really nice. There's r, that's our radius, right? So how am I going to find the radius in this situation? If you guessed, use the distance formula, because I need to know the distance between my center and that edge of the circle, you would be correct. So that means distance, in this case r, is going to equal the square root of, and then it's going to be the difference of my x's. So I'm going to go 7 minus 9 quantity squared plus 4 minus 10 quantity squared. You might want to just pause again and think, does this look similar to the equation of a circle? And can you make sense out of that? All right, moving on. So r is going to equal The square root of 7 minus 9 is negative 2, but we're squaring it, so that's going to be positive 4. And plus 4 minus 10 is going to be negative 6, but I'm squaring it, so it's going to be 36. I could do better with that square root. And yeah, r is equal to the square root of 40. I'm going to leave it like that because when I go to plug it into my equation now, I have my center. So I have x minus 9 quantity squared plus y minus 10 quantity squared equals the square root of 40 squared. It means I could just take off that square root because squaring a square root is the inverse operation. And then we're left with this wonderful answer. All right, so yeah, hopefully that was helpful. And you understand more deeply how to work with circles in a coordinate plane. Take care and be well.